Welcome class to Chapter 4, Working with Lists. With Chapter 4, I'm going to break the videos in two. So we're going to cover the objectives, looping through an entire list, 4 loops, avoiding indentation errors, making numerical lists, range function, and list comprehensions in this video. So back in Chapter 3, we talked about lists and how we could organize those lists and build lists. In this chapter, we're going to learn how to loop through an entire list using just a few lines of code regardless of the length of our list. Looping allows us to take the same action on a set of actions with every item in every list. So as a result, we have an efficient structure that will allow us to output what we need to output. So some examples of why, maybe why we would want to loop through an entire list. So these examples follow the projects that are in the back of your book. So if you look towards the middle of your book, you're going to start to see where projects develop. So let's see here, roughly about page 225 is where our first project, and that's actually what we're going to start to begin to build here in Chapter 4, and that's alien invasion. When you get done with project 1, look in your book, the second project is the second example. So let me just find that, and it's called data visualization. The third project in this book is called web applications. So the first bullet says there, move every element on the screen by the same amount. Well, we'll do that once we start populating our game with our aliens on the screen. And then the second project, perform the same statistical operation on every element. And that has to do with our data analytics or data visualization. And then the last one, display each headline from a list of articles for a web page. And that would be with our project 3, which is web applications. So just a note, we're only going to work on the first project, but I highly encourage you to, beyond the scope of this course, go through the second and third projects. So how do we go about looping through an entire list? Well, first we have to create the list. So in this example, it's magicians, and we have 3 items or 3 names, Alice, David, and Carolina. We use a for structure. So we say for, and then we have to use a variable here. And that variable could be many things. Here they're just using the singular version of that list. So for magician, in, and then the list name, magicians. You could say for value in magicians, for I in magicians. It really doesn't matter what you use here, as long as you don't use a word that is a keyword for Python. And then you just use that single value here to go ahead and either print out in this simple fashion or even a more with some F strings. So what happens is every time through it just grabs a list item and then does what the for body says, grabs the next list item, does what the for body says, next list item, does the for body. And then once we are done with the list, it just simply exits out of the structure and we're done. So for whatever variable, in, list, and then you have your colon. Colon is required at the end. And then make sure that you always indent, okay, the statements that are to be included for the for body. So looking at this example, the output would be our 3 list items. Notice that there's no \n here to do a new line feed. That's exactly what the for structure will do with regards to print statements. So we're going to expand that print and add a little F strings in and actually have 2 print statements. So this example is on the top of page 52. 51 has the first print statement using the F strings, and then we go ahead and build in the second print statement. So remember your syntax when working with F strings. So anytime you want to bring in a variable, you got those curly braces. And remember, you can apply methods to your variables. So this for will have two statements that will output for every value in the list. Okay, so if I want an additional line, I will put in the /n. If I only want the current line feed, you don't need to code the \n. Okay, so 2 lines, Alice, that was a great trick. Alice, that was a great trick. I can't wait to see your next trick, Alice. Okay, new line feed, blank line in between, and then David, and then Carolina. Well, what if we want to do something after the loop? Well, we just simply take our next print statement and we outdent it back to the left margin. So when I hit enter here, I'm going to have to hit my backspace key to take me back. So now my output has my 2 lines for every item in the list. And then lastly, thank you everyone, that was a great magic show. So again, indent when you want it to be included for every item in the list, outdented back to the left margin when you want it to be outside of the for body. So let's talk a little bit more about some indentation errors, and maybe some things that you'll encounter. So Python uses indentation to determine when one line of code is connected to the line above it. Okay, so forgetting to indent is this example. So let's go ahead and just practice this. So if I forget to indent these, or you shouldn't forget because your editor pushes them in, but let's just say you did this, you get an indentation error, expected in indented block, because that's the structure of the for. It has to have at least one statement that's indented. So if I do it this way, this line is the only one that is part of the for, and then this one that's over the left margin, these are the ones that end up just after the for structure is exited. So indentation, very important. Common indentation errors continued, forgetting to indent additional lines. And so I just demonstrated that, and that's what we call a logical error. That it still runs, but it's not the output that I intended to have. I intended to have, I can't wait to see your next trick for each magician, but it only happened for Carolina, but it really didn't happen for Carolina. It just was the statement that happened after the list was exited, which the last item was Carolina. Indenting unnecessarily. So sometimes we'll just maybe think that we need to indent print statements for no reason at all. So let's just say that we didn't have a for structure here and we ran it this way. So this is indented, but there's no for structure. So it says indentation error, unexpected indent. Okay. You might encounter this more when we start with alien invasion and just trying to interpret how the author wants you to lay out the code. But remember that you only indent when you're part of a for. Indenting us unnecessarily after the loop. So if we go back here and indent, get my right line here. So those two are intended to be part of the loop, but let's just say we forgot to outdent this one. So the output like this, we got our first 2 lines, and then we have that new line feed, which is the blank, and then it says thank you everyone. 2 lines, blank line, thank you everyone. 2 lines, blank line, thank you everyone. Okay, so not what we intended, and again, that's a logical error. It still runs, but it's just not the intended results that we wanted. Forgetting the colon is another syntax error. So if I forget to have my colon, syntax error, invalid syntax. So it'll point right to the end of your list name here, flagging you that you forgot your colon. So jumping from our for structure into making numerical lists. Before we do that, let's look at lab 4-2 animals. It says think of at least 3 different animals that have a common characteristic, store the names of these animals in a list, and then use a for loop to print out the name of each animal. Okay, so 3 animals, store them in a list, and then use the for. So modify your program to print a statement about each animal, such as a dog would make a great pet. So you're going to structure this one very similar to this one. Okay, so you might not have 2 print statements, okay, just one for the for body. Okay, next section, making numerical lists. So there are many reasons why numbers are important in our world. So to keep track of the positions of each character in a game. So back to our alien invasion. Exactly where do our aliens need to be positioned on the screen as we're playing the game. We can keep track of our players' high scores in that game. And then when it comes to that data visualization or data analytics, an example of it would be temperatures, distances, population sizes, latitude, longitude values, and all of these could be incorporated into some sort of a web application. So to print a series of numbers, we have the range function, and the range function is a beauty. So what you need to do is think about where you want to begin and then one number beyond where you want to end. So in this example, we start at 1 and we go to 2, 3, and 4 because 5 is 1 beyond it. So if I wanted 5 to be part of this, I would have to say 1, 6. So again, you come up with the name of the variable want, make sure that you have your colon, make sure you indent, and then go ahead and use that variable to output. Now range you're going to see in many different ways in this next section used, and so they're exciting ways in my opinion. This one is very exciting to me. Make a list of numbers using range. Okay, so we can use list, but we use range within list. So list then creates the list that we need, but range specifies exactly what's going to be inside that list. Okay, so here we have a range from 1 to 5 because we go 1 beyond that, and it creates that list. And when you do the output of the list, which is numbers, you get those square brackets. Okay, so it's not like we're using a for structure to go through the list. We're building the list in this example. Now if I want to skip numbers for whatever reason that may be, here we're going with just even numbers. So we start at 2, we want to go to 10, so we use 11, and then we go every 2. So if I needed to go every 3, I'm going to put 3 at the end. Okay, well, I should just even notice that I misspelled squares up here. So you're going to be using those ranges. So let's, before we talk about squares.py, let's just look at some of the labs on page 60. So, no, 4-7, we'll start there. Make a list of multiples of 3 from 30, or of multiples of 3 from 3 to 30. So the last example that we just went over is going to be your template for that. Okay. 4-5, I guess you could have went over that one first. Summing a million. Make a list of the numbers from 1 to a million. So our first example that you see up here. And then use a for loop. So you're going to have to take what we just talked about in the earlier section and then loop through that list, outputting each of the numbers. Okay. If you have a slower processor on your computer and it starts to get laggy, you can go Control C. But 1 to 1 million, not 1 to 999,999, 1 to 1 million. So make sure that you code your range accordingly. Okay, so let's jump into the next section of squares.py. Okay, so squares.py uses range, it uses for, and it also uses exponents, and it uses append as well. So what I did with the students on campus is I said, close your book and let's just go through this. So I'm going to do the same thing with you. So I want you to close your book while you're watching this video and go through this, and let's see what we can come up with together. Okay. So let's save this as squares, spelled correctly. Gosh, squares.py. Okay, so we need to first start off with a list. Now that list is going to be empty. And if you remember from chapter 3, we can create an empty list just by using the square brackets. Then we use the for structure. So we're going to say for, and then I'm just going to use value. Again, you could use I. That's a typical programming counter to work with. But I'll use value. And then we're going to do in, okay, and we don't have a list, okay, because we're trying to add items to our list, but we know a range. And your range can be very different from what's in the book. On campus, I think we did 1 to 128, I think, is what the students picked. Right? And then what we need to do is take 1 and square it, 2 and square it, 3 and square it, 4 and square it, 5 and square it, all the way up to 128 and square it. So we have to come up with that formula. So we use a variable called square, and we assign it value raised to our second power. So every time we go through the iteration of this range, okay, and again, I'm just going to put this over here. 1, 2, 3, 4, 5, 6, 7, all the way to 128. Okay, and we're going to square each one of those. So 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16. And that's going to be assigned to square each time we run through the for loop. Then we need to take that value that we just calculated, 1 squared is 1, 2 squared is 4, and we needed to add it to our list. So in chapter 3, we learned that we can use the append method to do that, and the value that is holding our calculation is square. When we're all done, we exit out of the for and we print out squares so that we can see our output. Okay, so quick calculation in 0.2 seconds from 1 to 128, all of our numbers squared. Okay, so that is your squares.py. Now there's 2 other variations to this. I'm going to talk about the one on page 59. Okay, so instead of having this variable hold our calculation, we can go ahead and just put the calculation in the append. So I can take value to the second power, and I can take this line away. Same calculation or same results. Okay, so either way, whichever makes you feel comfortable. You're actually going to use that in 4-8. 4-8 says a number raised to the third power is called a cube. So 2 cubed, okay, so 2 cubed would be 8, okay, and then you're going to make a list of the first 10 cubes that is, okay, the cube of each integer from 1 through 10, and use a for loop to print out each value. Okay, so this version or this version, you could go about doing that. So you could change this to cube, cube, and then you're going to have to change what you're coming to, and then whatever range. If you want to go beyond 10, that's fine. Absolutely. Okay, so use this squares.py to build your 4-8py file. Okay, the last thing we're going to talk about in this lecture video is list comprehensions. Or actually, before I get that, let's come back to this one. Let's jump to list comprehensions. Generate the same list in just one line of code. So we can take and modify this statement here to incorporate the calculation, and then we don't have, we have the for kind of built into the calculation as well. So the code is on the top of page 60. Okay, so we would say squares. Actually, yeah, squares here. Here is our calculation of value raised to the second power for value in range. Okay, that's all we would have, and then we would go ahead and print out our list at the end. So value calculation of how we're getting this value right here. So for value in range, so 1 squared, because we're using the second power. Okay, so the calculation here, for structure here. Okay, so we need to close this with a square bracket. Close this with a square bracket at the end. Okay, so value calculation for value in the range, all enclosed in the square bracket. So no colon or anything like that. Okay, and again, the same results. Okay, so that's 4-9, the cube comprehension. So you're going to take what you see here as an example of squares.py, and you're going to convert that over to cubes.py or 4-9py. Okay, so let's jump back to that slide that I skipped over. Using simple stats with a list of numbers. So we can do min, max, and sum on any type of list that has numerical values. So again, when you see the 3 greater than signs, that's simply indicating that we're at the terminal and not in Sublime, but you could certainly use this in Sublime. So with that said, we could have list, and then we would have, actually let me not use that, range 1 through 11. Okay, so that is that, and then we could go ahead and go print min squares. Let's see if I got it coded right. Okay, so that's the minimum amount of our squares, so 1 squared is 1. Okay, if we do the other way and do max, we have 10. Okay, and this isn't actually squaring it, so let me just put in here numbers instead, because we're not doing that calculation of raising it to the second power. So let's make it make sense. Okay, so my max number there is 10, and then if I want to sum them all, I can do sum function numbers. Okay, so if I take 1 and add it all the way through 10, I get the value of 55. Okay, so that takes me back to 4-5 when I was talking about summing a million. So you make a list, and then you go ahead and use min, max, and sum on them. Okay, so if you have any questions on any of these labs or just this section in general, please let me know. Thank you for your time.